How'd you like to listen to .NET Rocks with no ads? Easy. Become a patron. For just $5 a month, you get access to a private RSS feed where all the shows have no ads. $20 a month will get you that and a special .NET Rocks patron mug. Sign up now at patreon.netrocks.com. Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And this is the coming out on the 21st, so this is the last .NET Rocks show published before Christmas, but
right.
We've got a few more to record.
Just geek outs.
How you been, man?
Oh, I've been working on the scripts for the geek outs. Turns out it's a lot of stuff. It's been a busy year.
Yeah, sure has. Yeah.
How about you? What are you up to?
Well, last night I did my first recording of one of my songs in the new studio.
Ooh, a new track.
It's an older track that nobody's heard yet.
Okay.
But the first recording I did was all kind of discombobulated. It's slower. It's at 100 BPM.
Right.
And with acoustic strumming and picking and stuff, and therefore it's very easy to get off time. So I want to tell you about the cool stuff that I did this with. I recorded the acoustic guitar and the bass first, and then I used Studio One's bend tool to quantize the audio.
What?
Quantize the audio. It basically worked right out of the box. And I had tried it before, but it hadn't really worked well. Maybe the default settings are good now, but what it does is it finds the transients according to your quantized value, eighth notes or whatever.
Right.
And then it essentially moves the transients and either stretches or compresses the audio between the transients and basically turns it into quantized, like it's right on the beat.
Okay, so it's just like making the beat perfect.
Yeah. And it does not sound artifacted at all.
Interesting.
To me, anyway. So then I did the same thing with the drums. For the drums, I used my iPad at the drum set because it's all the way across the room, right?
Right.
And the iPad, I installed this thing called Studio One Remote. And so I set markers in the 3 places where I wanted to record drums. And I could just go back, undo, record. So I did all the recording from the drum set with my iPad on a music stand. And I did 2 sections, one with brushes and one without. And that it took a while to record, but it was great because I could just take another take, do another take till it was right. And then I quantized the drums.
Those drummers are never on beat anyway.
I was pretty close,
yeah.
But I wasn't perfect, and I really wanted this to be tight.
Interesting.
And it really is. So I'm very excited. Everything worked, and yeah, what can I say? Very happy.
The new studio.
Yeah. Fully operational.
Nice.
Hey, let's get started with Better Know Framework.
All right, man. What do you got?
Well, I found this post on boardpanda.com. Have you ever seen that crazy site?
Yeah.
Yeah. So this is 30 of the worst Christmas gifts people ever received as shared in this online group. One of my favorites is a dish towel. I was 8. I was 8 years old, and my parents gave me a dish towel.
Nice.
And it wasn't even a new dish towel.
Time for you to learn.
It was just like they went to the kitchen, found a dish towel, wrapped it up in paper, and then gave it to this 8-year-old kid.
I love it.
Yeah.
Bad Christmas presents.
So hours and hours of fun and yucks. And silliness. Yeah. Which we need once in a while, right?
Yeah,
especially around the end of the year. It's like we've been working hard all year. Now let's take some time.
Awesome.
Anyway, that's what I got. Who's talking to us, Richard?
I grabbed a comment off of show 1873, the one we just published a little while ago with Leah Melanino from NDC in Porto. We were talking about sustainable development, just thinking about the energy consumed. We got a great comment here from Jackie who said, hi, Carl and Richard. I want to express my thanks for tackling this important subject. This conversation resonated with me a lot as I'm a software engineer working with Azure Cloud Technologies. And on a related note, I'd like to share my recent experience with an iPhone.
Yep.
I've always been an Android user, primarily due to the perception that iPhones are overpriced to non-standard devices. I think Apple pretty much dictates the standard. Just look at what they did to RSS. Often seen as more suitable for users seeking opinionated UX, like my mother, or a symbol of social status, like my brother. Jackie, like you're dissing the family.
I know, right?
It's Christmas. However, when my Google Pixel broke and I had to let it in for service, I was left with no choice but to use a backup iPhone 5S, a decade-old model offered by my brother. See, he may be a social status seeker, but at least he'll give you a spare iPhone. It's not a bad guy.
He's not a bad guy.
Yeah.
You got to reassess this relationship, man.
And to my surprise, the iPhone 5S was still receiving security updates, and all my essential mobile apps function flawlessly on it. This is something I couldn't even say about some 5-year-old low-end Android devices. Not that any iPhone's a low-end device. The only drawback was battery life.
Well, it's a 5S.
Battery's not going to be great. This experience made me realize that even though iPhones may not be considered entirely sustainable due to a lack of adherence to certain standards like USB-C or replaceable batteries, their longevity is great. Right up until you drop them. Therefore, I've decided to opt for an iPhone model with a USB-C port. Thank you, EU, who demanded that Apple start using USB-Cs. This will allow me to utilize most of my Android gadgets and extend the lifespan of the phone. And thanks again for your dedication to the .NET Rocks podcast. It has been a valuable source of knowledge and inspiration, especially during my career transition to .NET C#. Looking forward to future episodes.
And I can add to that. The iPhones are inherently more secure than Android phones just because Apple is such a closed system. That's one of the benefits actually of having.
It's sort of security by obscurity. Nobody wants to try and hack them, really.
Well, I don't know about obscurity, but security by iron fist control over everything, everything that goes on that phone. Right. So that's one of the reasons why I have an iPhone. And the guys at security this week, Patrick Hines and Dwayne LaFleur, say the same thing.
Yeah, get the iPhone.
iPhone is more secure. The Android phone.
I mean, under the hood, Android's Linux. Everybody knows Linux is terrible, especially Daniel. He knows that best. I'm just going to poke at the Linux guy the whole day.
Is that what we're going to do? We're going to poke at each other at Christmas time? Come on.
Hey, Jackie, thank you so much for your comment. I'm glad you really like the show. And a copy of Music to Go By is on its way to you. And if you'd like a copy of Music to Go By, write a comment on the website at .netrocks.com or on the Facebooks. We publish every show there. And if you comment there and I read it on the show, we'll send you a copy of Music to Go By. And
you can follow us on Twitter if you like, but the real fun happens on Mastodon. I'm at Carl Franklin at techhub.social.
And I'm Rich Campbell at mastodon.social.
Send us a toot. You might get a mug if we read it on the show.
I don't think so. Pretty sure you won't. Yeah. Pretty sure you'll get a copy of Music to Go By. Kind of how that works.
Did I say mug?
You did.
All right. Let me say that again, Brandon.
All right.
Send us. Although that was kind of funny. We might want to leave it in.
It was kind of funny. I'm pretty sure you won't.
Let's leave it in. It's Christmas time. What the hell? All right. Let me bring on our guest, Daniel Marbach. As a distinguished Microsoft MVP and software maestro at particular software, Daniel knows a thing or two about code. By day, he's a devoted .NET crusader, espousing the virtues of message-based systems. By night, he's racing against his own mischievous router hack, committing a bevy of performance improvements before the clock strikes midnight and he turns into a pumpkin.
Yes, exactly that.
What's a router hack? What are you going to do? Load WWRT onto?
No, it's a very simple sort of trick because I've been contributing to open source and various things, and I just like to spend some time with code because I feel like it sharpens sort of my understanding of the stack that I'm working with. And I had a period in my life where I just couldn't stop, right? Because it's like, and then at first it was like 1 a.m., 2 a.m., 3 a.m. in the morning. And then luckily, I always basically, my only one rule was that I will not extend my alarm clock to a later point in the day. So otherwise my days would have shifted. But at some point I was like, okay, that's it. I need to change something in my life. So basically, I'm switching off the internet around midnight at my home.
Oh, and that's when you have to hack your router.
So exactly, because that usually when you're like in the middle of something and there's, I should Google Bing this or whatever you're using, right? You're like, the internet doesn't work anymore. It has time until tomorrow. And then I switch off and just go to bed. So it's,
it never worked that way for me. I had to turn the bugger back on. I put the same rule in place because I had teenage daughters. And now you hear the audible groans at midnight, right? It's like, oh yeah, everybody's in bed. Sure they are. But me, it's like, I guess finishing up something, go to push the code, fails.
Yeah.
You're like, it's me. I got to fix the router.
So you're a performance wonk, are you?
Well, actually, I work for the company called Particular Software. I guess you had Udi Dahan on the podcast before, right? So he's my boss.
We've had a few particularites.
And a few others. And so I basically, my day-to-day job is I'm building robust and reliable frameworks and libraries for people that sort of want to sort of build distributed systems, primarily based on messaging stuff like Azure Service Bus, SQS, SNS, storage queues. In the old days, God forbid, MSMQ, right? But it's still out there, thriving. Surprise, surprise. Mm-hmm. It's quite heavily used. It
was good in its
the
day.
Industry. Yeah, and it's one of the great things is it's feature complete, right? It's just there if you're still running on Windows and not on Linux like I do. And it
ain't DCOM.
And one of the things that we do there is we want to make sure that the customers that are using Service Bus can focus on just writing their business code, don't need to write any plumbing code. And that stuff should run as efficiently as possible, right? So I guess performance, throughput was always sort of right front and center, sort of in my day-to-day job. But I also care a lot about it because I believe, especially, came also out in the comment, right, that you read out, Richard. There's like, if you're targeting the cloud, or if you're shifting to the cloud, or if you already are in the cloud, sort of you are basically built by the amount of resources that you're using in the cloud.
Yeah. So there's a direct revenue relationship to that consumption, which at least gives us some kind of incentive.
Yeah, correct. You put down your credit card and then you get surprises at the end of the month. Especially
surprising yourself is one thing. Surprising the CFO is another. Like, that's a very loud noise from a large office.
Yeah,
well, and
absolutely.
that begs the question. I mean, there's so many ways to tweak performance. One is just by using the latest .NET stack.
Correct.
And then, keeping your NuGet packages updated. But on top of that, what kind of knobs are you pulling? Are you pulling software knobs, hardware knobs, all of the above?
So let me quick, before I answer your question, let me quickly go to what you said about updating the .NET version. That's actually really interesting because Microsoft has this blog series where they essentially talk about their teams migrating to, for example, from .NET Framework to newer .NET versions, or from .NET 6 to .NET 8. And one of the cool things they blog there is that the Microsoft Teams infrastructure team, they basically migrated from .NET Framework to .NET 6. Yeah. And just by basically migrating to that LTS version of .NET, they were actually able to sort of by almost 24% reduce their monthly cost expenditure in Azure, which is pretty amazing if you think about that, right? And that's definitely one way to do it. So I always encourage people to sort of, if they can, stay up to date with the latest .NET versions. Definitely.
Yeah, I'm a big fan of that series on the .NET blog, just because you talk about like the Teams guys migrating to a new version of .NET. And the benefits they got from it, and also the things they struggled with on that, like what problems they had. But to me, more than anything, it's like, hey, if these guys got this kind of benefit and were able to move that big an app, you're going to be okay. Like you can do it.
Yeah, absolutely. But to come back to your question, Carl, I think one of the things that I try to apply to sort of in my thinking is I want to make explicit trade-off as I'm going with things. And so that means I want to be aware of sort of, is this code going to be executed on the hot path or at scale, right? So, and how many times a second is that going to be? Or is it just something that runs on a sort of a background job once a day or twice a day? Or because then usually if it's just executed once or twice a day, it doesn't really matter that much whether it's super fast or not. And then, but then when it's executed on the hot path, potentially hundreds and thousand times per second, then it's usually good to sort of become more of performance aware. And but performance aware, unfortunately, this is also something that gets thrown around quite a lot, sort of in the industry. And then everyone assumes everyone knows what performance awareness means, right?
Yeah.
But one of the things that I struggled with was, where should I even get started to become performance aware? Because apparently, if you go down sort of the literature of looking at benchmarking and performance optimizations, you can actually go from just doing little things up to setting up your entire CI/CD pipeline with dedicated hardware, doing regression testing, right? But usually we don't start there. Usually we start somewhere else, and that's one of the things that I'm trying to apply. So usually I ask myself a bunch of questions when I look at the code, right? So for example, I go and look for, well, what could be the CPU and memory characteristics? What could that be for the specific line that I'm looking at that I know is on the hot path? And then I usually start thinking about, so are there any sort of low-hanging fruits that I can sort of apply to this? Maybe do some more efficient string splitting options and stuff like that, that I know from reading the performance blog posts and I can apply there. And
that is, and I presume that's Stephen Taub's post you're talking
yes,
about.
of course. Yeah. The book of the Taub, right?
The Book of Taub, yes.
Yeah, exactly. And then most of the time, right? So there are a few tricks you can apply. So for example, if you're allocating a byte array, right, and you know that you actually just need it for every iteration, what you can do is you can sort of move that away from the hot path, allocate it once and clear it. And then you're no longer having allocations that you're executing like on the hot path. And then the garbage collection doesn't have to clean up a lot of things, and there things get better as well. But then,
how do you measure that, Daniel? Like, how do you know it got, like, that's a tricky one, that
correct.
The impact of garbage collection, like, how would I measure that I reduce the amount of garbage collecting going?
Yes, that's a very good question. So usually what I do is, I call this the performance loop. So for lack of a better term, I call it the performance loop. So what I usually start with is when I have a hypothesis about a piece of code that it creates garbage, then what I do is I write a test harness. And essentially what that harness sort of does, it sort of takes whatever I'm looking at, takes it into a specific context of my suspicions, and then it executes it in that specific scenarios, and then I attach profilers to that piece of code. Right. And what I usually do is I take at least a memory snapshot, and I also create a CPU snapshot. Because and of course, if you have an IO-bound system, like you have a database in place, or you have HTTP calls, stuff like that, you also want to look at your IO. You want to do IO-based profiling as an example, right? Because usually when you look at your IO system, like the database, you can basically achieve orders of magnitude of performance improvement by tweaking your SQL queries, right? Before you even start thinking about memory allocations and stuff like that. But assuming you have sort of removed that part, then essentially those sort of profiler snapshots give you an indication of where could you focus on. And here comes the next problem, right? When you attach your profiler, is that you might see lots and lots of allocations from different subsystems and components on that specific call tree. And where should you even start? So I usually try to sort of apply a combination of, I call it the 1% improvement philosophy, versus deliberate contextual based optimizations that I want to do. So, because, for example, I believe that if you do enough little performance optimizations over time, that's the 1% improvement sort of philosophy, then eventually they will end up making a big impact. And we can see that Microsoft applies it as well to the .NET runtime, right? They're doing lots and lots and lots and lots of small changes all over the place. And the compounding effect of these changes, they essentially are massive when you look at them in sort of the greater scheme of things.
Right. What profiling tools are you using here? Is this just like the built-in profiler?
Okay, you made a joke about me running on Linux, right? So,
I knew it wasn't a joke.
Well, so I'm a big fan of the sort of JetBrains tools. I've been using them for years.
You're not alone.
So I'm using usually .trace and .memory, sort of those two tools, and Rider also has some built-in analysis. So, for example, they do, when you execute your tests or you execute your solution, they also do some dynamic program analysis where they show you sort of the allocations that your stuff had or the CPU that it wasted. So I try to use those tools, but primarily .trace and .memory to get an overview of what is actually going on. Yes.
Right. Yeah. And I mean, yeah, there are built-in profilers, but if you're willing to pay for one, there are better ones.
I mean, to be fair, Visual Studio is great, right? There's like Visual Studio has, depending on the license, I'm not entirely familiar with the licensing terms there, but it has great tooling built in. Or if you are sort of very advanced and mostly on Windows, you can also use Purview, right? So Purview is a very powerful tool that you can use. Although I struggle with it a bit, I must say, every time. It's like using WinDBG. Every time I use these tools, I have to sort of get some cheat sheets onto my machine in order to remember the complex commands. And that's one of the benefits those tools have.
They are tools you need to learn. And I mean, I suspect you use them more than most people. And if you can't keep them in your head, then nobody can. I mean, I've done a lot of performance tuning over the years, and people are always surprised. It's like, why are you reading the docs? Like, don't you know this? It's like, listen, there's a lot of knobs on these things. And if you don't go through the steps, you can waste a lot of time.
Yes. And actually wasting a lot of time, that's actually a very good sort of comment that you made there, because I think even if you are more familiar with performance optimizations and benchmarking, it's like and profiling, at the end of the day, that's not my day job. My day job is building robust and reliable messaging frameworks and middlewares and the platform in particular, and not doing performance optimizations all day long. That's not my job description, right? And I guess that many people that are also listening to that podcast have the same thing, right? They would like to dive into profiling and benchmarking performance optimizations, but they only have a limited budget in order to spend on those types of things. And that's why I always recommend start with a test harness, reproduce a scenario, attach your profiler, and then use your domain knowledge of the things that you're working in to basically sift through the noise of allocations and CPU and on the call stack, and then figure out, okay, probably here is where we can make the biggest impact on sort of reducing the numbers of CPU cycles spent or reducing the numbers of garbage allocations that are happening there. But sometimes, like I said before, it's also where you think you have the most knowledge in, and then applying sort of the 1% improvement over time in order to sort of make things better and better, and not trying to gold plate so everything out of an existing code path. But I guess we now have sort of touched a little bit on the how would I even know where to get started, right? We talked about profiling, we talked about doing CPU and memory at least, right? Always get sort of two views on the code base. But the next thing is then, improvements, of course, that goes more into the territory of knowing your stack, knowing your language, knowing the libraries that you work with. Like Carl said, also looking for, has the library a new release that we can pull in? Or maybe reach out to the maintainers and say, hey, by the way, we did a profiling snapshot and we found out that this library allocates that much amount of memory. And guess what? When you reach out with a profiler snapshot to third-party tooling providers, they're like super happy because you're then in the 1% sort of customers. And then it's like, hey, now we have data from the customer. We can see what's actually going on.
You've now described a workload in a meaningful way to them.
Correct.
Yeah.
Right. And so, for example, I myself have done that as well. At some point, I stumbled over sort of memory inefficiencies in the Azure Service Bus SDK. And then I had a hunch. I wrote the test harness, attached profiler, was able to show that when you access the bodies of a Service Bus message, it allocates unnecessary memories every time you essentially access the body. Was able to sort of show the profiler snapshots, show the memories, and then because I was lucky, I already knew the library a little bit, I guess, and I was able to contribute a fix for that memory allocation problem to the Azure Service Bus SDK.
Yeah, that's a good way to get an email from Clemens.
I've had comments from Clemens originally on some of my pull requests as well.
Right.
Gone through that.
And therein lies the point. Like, you're getting into it, and of course, the kicker, of course, is that it's open source, so you could just contribute a fix.
Yes, yeah. But I guess, nobody expects you to, right? But at least having a memory profile or a CPU profile, and like you said, Richard, showing what's going on in production is a good thing.
Yeah, I just think it's always challenging to get down to the brass tacks like that. Like, to me, most of my profiling experience has been trying to optimize an e-commerce site, where it's like we're now looking at a buy of more servers because the site's so busy. Like, an optimization can mean a lot of money, and and I was a Nance guy at the time, and that was the tool that showed me. This may not have been. It was always that balance between, this is a very complicated method, and so it's consuming a lot of resources, and it's a very simple method, but it's called hundreds of thousands of times. And so the fact that the tool would help sort out that weight of often called and so worth minute optimizations will make big differences versus rarely called but complex enough that you will get some return on that. I never worried about optimizing admin calls because it just didn't called that often. But all of that mainstream shopping cart, recommendation engine, custom render pieces, ad pieces, like those were all the things where it's like, these get called a lot, even though they don't look that big. And just playing with string compilation, like those kinds of things, made a huge difference in the end. But the challenge, I think, for a lot of folks is they just want to get into the code, and this idea of you snap the harness on first and get a baseline set of profiles in place. And then, as you said, the magic word, the hypothesis says, if we do an optimization here, it'll make a difference. Now you go tinker, then run the benchmarks again and say, did we make a difference? And king. And if you didn't, revert.
Yes. Yeah. And
because there's no performance code I've ever written that was easier to read than the original.
Yes.
Ever.
Absolutely true. And I think what you said is super crucial. That is sort of the performance loop that I apply is, so when you have the harness, and then usually that reproduces the scenario, right? And then, like you said, you do the improvements. That might be several iterations of ideas that you tinker around with. And then you might execute several benchmarks to sort of look at those sort of optimizations that you're doing. Maybe even several micro benchmarks, sort of measuring sort of little improvements in that call stack that you came up with during that tinkering phase. And then at the end, what you do is you bring it back into that harness, right? And then you look at sort of the end-to-end profile again, where you look at, again, the CPU and memory profile at least, to actually see the before and after, right? And then you see on your graphs, we spent 650 megabytes of memory on that specific scenario before. Now we're at 600. Now you know that you actually have gained something. And you also have the numbers that from the benchmarks that you run against each individual part of the call stack that you try to optimize. I have one question to you, Richard. You said you used ANS Profiler. Do you also happen to sort of, because I had a period where I used several tools because I had sort of, I know it when I see it type of investigations. Right. So I used several tools that had different sort of dashboards and overviews that sometimes gave me sort of a slightly different view based on the preferences of the tooling against the test harness. And then I was like, oh, there it is.
Yeah, I mean, different problems in different spaces. And granted, a lot of my experiences are from a while ago where there wasn't as many tools as there are today. But yeah, definitely there's a difference between tweaking a piece of code that, sits in a call stack for a web page and understanding a sort of end-to-end run where it's like, oh, the real problem here is that there's a repeated call to a database enough that it's doing a reauthenticate in the middle, or it's forcing a recompile of a stored procedure. Like, by the way, on the day you find one of those from a method call and you got all the way down to, but we call it this many times, and so it forces this recompile and that creates this overhead. Like, that's a very good day, because those are hard to find. Like, just a tough place to get into. But, your point's well taken. Each tool provides its own view to that. And we ended up, I think it was in Dynatrace where we were finally able to see, this is a multiple database interaction problem before we really saw the behavior correctly.
Yeah.
And guys, I want to pause for just a few moments for these very important messages. And we're back. It's .NET Rocks. I'm Carl Franklin. That's Richard Campbell.
Hey.
And that's Daniel Marbach. We're talking about performance, squeezing performance out of our applications. And Daniel, right before the break, you were going to make a point about memory allocations.
Memory allocations, yeah. So what I wanted to say is I feel like I need to sort of clarify one thing, because I talked a lot about sort of memory allocations. I also sort of highlighted a little bit the CPU stuff, right? But people might get sort of the message that all that matters is memory allocations. And I definitely don't want to say it that way, because I just feel like, for me, I've always sort of started looking at memory allocations because I've seen that these are the areas in the applications that I worked with and the systems that I worked with where I can make the sort of the biggest impact to reduce the GC overhead without sort of going into sort of the algorithmic complexity and stuff like that sometimes comes with tweaking algorithms where CPU cycles are spent. And I remember, I don't know the exact quote, but David Fowler once sort of tweeted, or is it still called tweet? I don't know. But he shouted into the interwebs that essentially, apparently, memory stream 2 and other sort of 2 are still the biggest source of memory allocations in .NET systems out there. Wow. Which kind of shows how important sort of thinking about memory allocations actually.
And certainly in this case of scale, that, when we're dealing with lots of iterations, again, I come from the e-commerce space. The other thing I ran into was we typically had to build our load tests to run for longer because you needed to get into multi-generational memory to actually understand behavior in production. That lighting up a load test that ran for 10 minutes and wrapped up didn't give you the same results as what was actually happening with your server, which was 2 days in. Because the way that memory gets allocated over multiple generations became a huge part of the problem. Not that we had to wait 2 days, but often we had to go a couple of hours before you actually get that Gen 2, Gen 3 reshuffling of memory enough to say, this is fully fragmented and restacked memory a few times. And that's when those orphan long duration objects created problems for us. So like, there's this chunk of memory in the middle of the pool and it's been there for 2 hours. And what the hell is that? Because it's screwing up every GC. But you only found that from these longer runs.
Daniel, is there anywhere that replacing a task with a value task will be a problem. I mean, that's a common way to reduce Gen 0 allocations is to use value tasks.
Value task is definitely an interesting sort of a newer-ish addition to .NET. I know that this is a little bit of a controversial topic because some people are like, yeah, you should be using value task everywhere. I'm more sort of in the camp of use it where it was designed for, which is for IO-bound paths, where you essentially have the majority of the calls are sort of getting a cached value. And then only I don't know, out of 10 calls, maybe 1 or 2 are actually doing the actual IO operation. That's where I feel like value task is sort of a neat sort of approach to sort of make sure that you don't have that many allocations anymore. But to be honest, I think in most systems, when you have to sort of do that type of optimizations, then you're already super far, because I bet many sort of applications, systems that are running on top of maybe ASP.NET Core or some others, they have other problems like memory stream, 2-array, unnecessary byte array allocation, stringifying stuff that doesn't need to be stringified, all sorts of that stuff, instead of really thinking about switching from task to value task.
How about switching from Web API to gRPC? That's a good one.
Yeah, I mean, even for example, switching from Newtonsoft JSON to system text JSON, right? Or using source generated system.
I'm sorry, which one's faster? Are you going to touch that?
No, let's not go there. Let's not.
Well, I mean, you open the door, so you might as well walk through it.
I would much rather talk about, I don't know, Swiss cheese or something like that than talking about that. No.
Well, I mean, we don't want the listeners to get the impression that just by switching from Newtonsoft to system text JSON, you're going to find a performance improvement. Did you really mean that?
So we actually have seen, when we switched from Newtonsoft JSON across the board, quite hefty improvements, especially when combined the system text JSON serialized combined with source generated approaches, where you also sort of are more AOT friendly. As an example, you have faster startup times on Azure Functions or AWS Lambda. So there is definitely merits to that, but I don't want to say Newtonsoft JSON is bad. I think it has its place.
Well, the same guy's working on system text JSON. I mean, it's James Newton King.
Yeah, exactly.
And gRPC Web, right?
Exactly. Yeah.
He's doing all that stuff. I also think
being part of that newer version of .NET and integrated with that team, like there's a lot of performance people there. You just have the resources.
Yeah.
Like if the eye of Sauron that is Stephen Taub is paying attention to your code, your code's going to be faster.
Yeah.
That guy's amazing.
But again, I mean, if you have your harness and you attach it and you do some profiling and you find out that the serialization subsystem is actually the problem that makes everything so much slower, then that change makes sense. But I guess there are also other areas of improvement that you can sort of leverage. But I would like to, if you don't mind, I would like to switch a little bit into sort of the benchmarking stuff, if we still have some time.
Sure.
Is that okay for you?
Yeah, go for it.
Because Richard and I, we talked about this as well in recently in Warsaw and in Porto about benchmarking stuff.
I think that was a point where I said, "All right, we need to make a show about this."
Yeah. So one of the things that I found really interesting is when the first time I sort of got into contact with benchmarking was, I read lots of blog posts about benchmark.net, and sort of I was looking at sort of these benchmarks out there. It's like, it's easy. It's like a unit test, right? It's like I've written plenty of unit tests with X units, God forbid MS test or whatever, right? So it's like, I know this. It's not going to be difficult. But I was quite surprised that essentially you're required to have a different understanding in order to have a good benchmark. And one is a unit test has two states, right? It's either red or it's green. So it's
pass or fail.
Pass or failed, right? But a benchmark is something really different, because what a benchmark does, it essentially, especially when using benchmark.net, by the way, excellent tool. Shout out to all the people that have been involved there.
Indeed.
It's like you are executing a given scenario under hundreds and thousands of iterations. All right. And so what it means is there is no pass or failed. You basically get sort of standard deviations. You get GC. You measure the GC involvement and stuff like that.
Right.
So that's what a benchmark is, right? But it doesn't just start with understanding what the benchmark is. It also goes to how should I even put my code under a benchmark harness?
Right.
And that turned out to me the really tricky part, because I was only reading about this. Oh, here is a before and after comparison between string concatenation, a string builder, and the value string builder, which is the fastest, right? Super easy scenario. But when you're actually taking your production systems code that you had under a test harness and you sort of filtered in and say, okay, there is a bunch of things that we need to improve, and then you want to measure the before and after, how do you take this code, which is probably not just a public method on a static class that you can take and then put into a benchmark? How do you actually sort of make sure that you can measure what's going on, remove all the side effects that you don't want to have in your code, so that you have reliable sort of benchmarking results and that you can compare the before and after to? And that was the thing that I struggled tremendously with it. And I found my way sort of to do it, especially sort of when I was still sort of growing on before becoming performance aware. And that was essentially, I went with a very simple approach. I essentially took sort of the components that were sort of on that code path. I usually copy pasted the code into a sort of a dedicated source repository, stripped away all the unnecessary stuff. For example, when I had an IOC container in place, I removed it and I added a new of the thing that I wanted to new up. Or if I had IO-bound stuff and I didn't want to measure the IO-bound stuff, I removed it with a task completed task, stuff like that, right? And then I had sort of a dedicated code base that was in a specific state, in a controllable state, where I knew all the noise that I don't want to sort of measure is gone, and now I can focus on that specific sort of benchmarking scenario that I'm looking at.
But it is the unit test style test, effectively. It was like, just bench this piece so that I know I've gotten results from that. I'd also say, as a corollary to this, that you do get decreases in performance with later versions because you're doing more. And so often it's like, the whole conversation with the PM, because I've gotten a situation where we literally had benchmarks as part of the CI/CD pipeline. Now they're coming back and saying, hey, the new version is slower than the old version. It's like, the old version didn't do all these things you asked for. Like, this is the overhead for the feature you asked for. And that was getting into SLA rules and things, where it's like, the customer expects us to deliver this in X many fractions of a second. It's like, well, we're getting closer to the limit because the customer asked it to do more. Update the SLA.
But it's interesting that you mentioned that, because I think one of the sort of benefits of the approach that I just described is that you can easily get started with not even thinking about how can we actually capture regression, or where should we execute those tests? What is a reliable CI/CD environment in order to have sort of measurable and statistically relevant results from this environment, right? But what you're essentially talking about is sort of more regression testing as well. And there's actually a lot of great guidance, a little bit hidden in the .NET performance repository. I think it was also driven by Adam Sitnik and some other people from his team. I actually talked to him a little bit over the course of, I was preparing for a talk about this specific topic. I talked to him a lot about it, and they have a tool that essentially allows you to, when you're using benchmark.net, what you can do is you can actually execute benchmark.net against a specific version of a benchmark and a specific version of the code. You can store the artifacts, and then you can execute it again against the changed version, store the artifacts, and then you can use the compare tool that they have to sort of sort of create a diff between the before and after version, and then you can define the threshold that sort of determines when it was an unacceptable sort of regression. And then, for example, you can fail your CI/CD environment, but
because of performance.
Because of performance, right? But CI/CD is also interesting because Andrei Akinchin wrote an excellent blog post about this topic because he did as part of sort of investigations. He looked, for example, at GitHub action runners. And the result there is that you essentially cannot use GitHub action runners to actually do regression testing for performance because they're just so unreliable. So basically, you have up to 3 times different 3 times different memory and CPU difference between builds, right? So it's insane. So
wow, that's crazy.
Yeah, it's quite fascinating, right? So that means
it just means if you're going to benchmark this way, you have to control your CI/CD pipeline.
Correct, right? And you have to have dedicated hardware that you sort of put somewhere, or rent basically bare metal hardware and have a runner infrastructure that sort of allows you to sort of put those tests to that reliable hardware, and you can't use.
Sure, I mean, you're saying the cloud's not an option here?
Well, it is definitely an option, right?
Yeah, it's just you can't use the built-in infrastructure for this. You have to set it up. You have to write your own YAML. YAML. And I've done this. Like one of the issues we were dealing with is we were up to, I don't know, 3,000 or 4,000 different web tests we wanted to do, and they took a day. And we needed under 15 minutes. And so we would light up 20 instances of the site in the cloud and parallelize all the tests. My goal was always, by the time you got back to your desk from coffee, the test results were back and you had failed.
Yeah.
Right. Like that was because instead it's still in your head. Like what we realized was that the every minute that goes by after they've pushed, the code's leaking from their mind. And if it's a day, it could be anybody. Like they're going to have to start over, picking it back up again. But if we could get it to them in under an hour, like 15 minutes was the magic number, they knew exactly what I know what that error is, and off they'd go again. Like it just saves so much remediation.
Yeah.
So I jacked up the test bill because it saved the dev bill.
Amazing. Yeah. So, and again, I think it's all, when we talk about Azure DevOps runners or GitHub action runners, usually there is a shared sort of infrastructure that you have there, and so
it's not good for benchmarking.
Correct.
You don't know what performance you're going to get. No repeatable results, which oddly are necessary. But if you're talking pass fail, that's fine. You don't care if it ran twice as long, half as long. If it's just pass fail for functionality, that's just fine.
Correct.
No big deal.
Yeah. But again, my message here is I want to hammer this home. I think becoming performance aware, I think it's a journey. And you don't need to basically end up where we just, you will end up eventually there where we just talked about, with having potentially your own hardware if you need to do regression testing, but already sort of having your harness in place, understanding the profilers so that you can zoom in where you should actually make those sort of performance improvements, then using a tool like benchmark.net, which saves you a lot of headache because it's sort of is already designed to sort of mitigate the most.
It's all the stuff you'd end up writing for yourself anyway.
Correct.
So just use it. And a bunch of smart people are working on it.
Correct, yeah. And it mitigates
always
common
a good
mistakes.
idea.
And then you can start there, maybe copy paste your code at the beginning, isolate the things that you want to do, get started there. And then at the later point in time, when your company is already sort of more performance aware, you can start slowly introducing sort of more sort of mature ways of actually doing performance testing and regression testing all the way along.
Yeah. But what you're applying there is like, you're pretty far down the path at that point too.
Yes.
Like, to me, the big thing here is, when does performance creep into the requirements? Because a lot of folks, early days of projects, it's just not even on the radar. Right. But to actually file performance problems as a bug, to get them on the sprint, right, to be part of the conversation at all, like that's arguably the starting point of any of that path, is that it's bubbled up to the point where business cares about it. You know, the line I used to do when I did these talks was performance is like air. You only care about it when you don't have it.
Yeah. I'm a big believer in having non-functional requirements in the design and the architecture sort of built in, and having explicit discussions about non-functional requirements, and also prioritize them with your business stakeholders in order to make the right trade-offs.
Well, and you know, the sneaky part about that is let them tell you it isn't important. So later when they decide it is important, but you said, you know, because again, performance is one of those things where nobody cares about it until they do.
Yes, yeah.
Right?
Yeah.
If I suck the air out of the room, you're suddenly really interested in air.
Absolutely.
But
Yep.
And it's the same thing. It's like you never thought about, you know, you can debate all day a render time of 2 seconds versus 4 seconds. I'm sorry, I'm so web centric on this stuff. And that's not a big deal. Everybody knows that 30 seconds is bad. Right. And so that's sort of these kinds of thresholds. And it's hard to talk about that out of context. You kind of have to make a slow page for everybody to start getting, hey, slow page bad. Set requirements for minimum performance and figure out where they are. And the good news is, of course, there's lots of written documentation on this. Like, you don't have to invent the wheel.
And one of the things that I also really appreciate by doing these types of investigations is, and small improvements, is you learn a ton about the code path in question. And that gives you a lot of insights into a potential redesign in the future, right? Because so many people are just throwing out there, just rewrite this, right? But they have make it faster.
You're not going to make it better if you don't know what the issue is. Like,
yes.
I also find that most folks who spent time in the tuning part understand the execution path, like the behavior of the software, in a deeper level than a lot of the folks that wrote it in the first place. Because often you're just trying to get to the deliverable. Does the feature do the feature requirements that were there?
I know we only have a few minutes left, but at what point in your investigation do you consider re-architecture, which is obviously the most expensive and risky way to improve performance? But, you know, I mean, as you're going through a project and looking or a tool or something and looking at every little thing that you can squeeze out, and something jumps out at you, oh, well, you know, this should be refactored or maybe even completely re-architected. How often does that happen?
It's a difficult question to answer generically, but I can give you a concrete example. So I worked a lot, contributed a lot to the Azure Service Bus.NET SDK. And essentially, I think it was down sort of 20 pull requests on sort of the path where the Azure Service Bus sort of you get the byte arrays from Azure Service Bus and hand it over to Azure Functions or to your code that is running, where I did lots of tiny improvements until I actually understood sort of how the body management of the byte payloads actually really, really work.
Yeah.
And then, only then, I came up with a better idea how to sort of manage that body work from different aspects. And that then led to sort of even more orders of magnitude of improvement, how the body is sort of managed, and less allocations, more efficient in CPU cycles. But it was like, I think, okay, I contributed in my free time, whatever that means these days, when you're constantly online, right? But I contributed in my free time, I guess, over a year to this code base, until together with the team, we realized, there are actually things we can sort of really refactor and make things even faster. So I have the tendency to go a very long time on a specific code path before I even reconsider re-architecting or redesigning.
Yeah.
Of course, small improvements
That's what I figured too.
Can also sort of sometimes mean you're not newing up something, you're making something a singleton that previously wasn't a singleton or something like that, right?
Yep.
But
and if it's still not performant enough, that's when you think about re-architecture.
Correct. Because what's also great is, right, when it's running in production, it's making money, right? And it gives you insights about what it's doing. And when you're re-architecting, redesigning for that period of time, you have no validation whether the stuff that you're changing towards will work. And with the small improvements, you have constant feedback loops. And I feel that's super, super important.
So what's next for you, man? What's in your inbox?
Well, Christmas time, of course. Drinking way too much craft beer probably over Christmas time. A delicious stout or something like that.
What is this too much you speak of?
But
never heard of that before.
But next year I will be in .NET Day Romania at Irina's conference. I will be delivering a workshop about reliable messaging in Azure, sort of deep diving into Azure Service Bus, storage queues, event hubs, and event grids. That's going to be really interesting. And what else? I don't know yet from a conference perspective, but definitely sort of increase a little bit more my contributions to open source stuff, because I still have a few ideas to contribute to a few open source libraries.
Yeah, it sounds good. Well, Daniel, thanks for spending this hour with us. It's been great.
Thank you.
All right, and we'll see you next time on .NET Rocks.
.NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter banned by the FCC.